Now we will go for the derivation for the expression of the discharge over trapezoidal notch or weir. So the figure which is shown over there is trapezoidal notch. So in this figure you can see that height, that capital H that is shown over there, that is the height of water over the notch, and as well as the length of notch can be shown over there. So length of notch is the width of the base, which is, this is L. So this is L is your length of the crest of notch. So L is the, and capital H is your height of the water over the notch. So the derivation for such kind of trapezoidal notch is very easy. So if you look at this particular figure, this trapezoidal notch is a combination of a rectangular notch as well as a triangular notch. So if you look at the figure, your triangular notch is the combination of, if you look at this point A, C and E, and then the point D, B and F. So if you club this thing, this particular thing will look like a notch, a triangular notch like this one. You can see this is theta by 2, this is theta by 2, theta by 2. So this will be a theta. And another thing, if you go for this thing, so this is your point C, D, E and F. This is a rectangular notch, and if you club this thing, this will look like a trapezoidal notch. So the expression we have used for the triangular notch as well as the rectangular notch, if we just combine this expression, we will get a expression for a trapezoidal notch. Or the only thing is that the once we are going for the derivation for the actual discharge, both kind of rectangular as well as triangular notches, we have to figure out the coefficient of discharge. So if we can say that coefficient of discharge for the rectangular notch is your CD1 and this is CD2, then just multiplying the expression separately, we can just club this thing and we will get the Q actual. So let's see how we will get it. So this let's say the Q is the discharge over the rectangular notch, and this is a combination of Q1 plus Q2. So where this Q1 is the discharge over rectangular shape of notch, and this Q2 is the two half triangular notches, or you can say if you combine it, this is a triangular notch. So this Q can be written as, so Q1 is your 2 by 3 L multiplied by under root 2g h raised to the power 3 by 2 plus Q2 is your 8 by 15 tan theta by 2 under root 2g h raised to the power 5 by 2. And this is your theoretical discharge, and if you want the Q actual, you just need to multiply it by the coefficient of discharge. So if we are considering that this is different for this two different shape, so this is CD1 multiplied by 2 by 3 L under root 2g h raised to the power 3 by 2 plus CD2, the coefficient of discharge for the triangular section. This is CD2 multiplied by 8 by 15 under root 2g tan theta by 2 h raised to the power 5 by 2. So this will give you the expression of the trapezoidal shaped weir. So in this numerical problem, we will find out the discharge through a trapezoidal notch. So the problem says that find the discharge through a trapezoidal notch which is 2 meter wide at the top and 0.45 meter at the bottom and is 40 centimeter in height. The head of the water on the notch is 15 centimeter and CD for the rectangular portion is 0.62 while the triangular portion is 0.60. So we are very much aware that any trapezoidal weir is combination of the rectangular weir as well as the triangular weir. So in order to figure out the dimensions of this particular trapezoidal notch, which is given as to us that this is the 2 meter wide at the top, so that means this is 2 meter wide. Now what it says that 0.45 meter at the bottom. So this is 0.45 meter and 40 centimeter in height. So this is 0.4 meter. The only thing is that this value is not given to us. This value and so distance between these 2 points is not known to us. So first of all we have to figure out this value, and then by using this triangle we can figure out what will be the our theta by 2. Then we will be having a complete dimension of this particular trapezoidal weir. So let's find out. So let's zoom this figure. Now it is more clear to you. So first of all we will be finding out the values. So this bottom is 0.45 meter. So this overall length is 2 meter. So this particular portion which is shown over there in between this one will be equal to the 2 meter plus, let's say this distance is no. So let's redraw this thing. It will be making more clear to you. So this scenario is such that this look like this one. Now this is 0.45, then again it is 0.45, and overall value is 2 meter. So let's say this value is not known to us. This is x, so this will be also x. So 0.45 plus 2x is going to be equal to 2 meter. So x is 2 minus 0.45 divided by 2. So this value is coming out to be 0.775 meter. Now again if we go for the determination of the theta by 2, so theta by 2, so this value is 0.4 meter. So this height is 0.4 meter. So now the problem is such that our x value is 0.775 and this is 0.4 meter. So this is your theta by 2. So tan theta by 2 will be equal to 0.775 divided by 0.4. So theta by 2 will be equal to tan inverse of so this value is coming out to be 62.7 degrees. Now theta is now known to us. Then we will find out the discharge through the trapezoidal notch. So that value is Q is equal to 2 by 3 CD1. So CD1 is we are considering that this is the rectangular one. So the CD for rectangular portion is 0.62. So this is 0.62 multiplied by L. So L is the this portion is L is 0.45 multiplied by under root 2g. Under root 2g value is coming out to be 4.4294 multiplied by h raised to the power 3 by 2. So your h is 0.4 meter. So 0.4 raised to the power 3 by 2 plus 8 by 15 multiplied by CD. So CD of the triangular portion is 0.6 multiplied by the tan theta by 2. So we have already figured out that tan theta by 2 is coming out to be this value. So we need not to put again the theta by 2 is equal to 62 point and then figure out. So this value is coming out to be 0.775 divided by 0.4 is coming out to be 1.9375. 1.9375 and then multiplied by the under root 2g. Under root 2g is again coming out to be 4.4294 multiplied by h raised to the power 5 by 2. Now, so again h is your 0.4. So this is 0.4 raised to the power 5 by 2. So we have to just calculate the values. So we will be having the answer that will be equal to, so this calculation is giving out to be q is equal to 0.4863 meter cube per second. That is the our answer of this particular question.